This is day 24 of Advent of Code 2023, and this challenge is called Never Tell Me the Odds. It seems like something is growing wrong with the snowmaking process. Instead of forming snow, the water that's been absorbed into the air seems to be forming hail. Maybe there's something you can do to break up the hailstones. Due to the strong, probably magical winds, the hailstones are all flying through the air in perfectly linear trajectories. You make a note of each hailstone's position and velocity, the input. So for example, XYZ, then velocity, XYZ. So each line of text corresponds to the position and velocity of a single hailstone. The positions indicate where the hailstones are right now, at time 0. The velocities are constant and indicate exactly how far each hailstone will move in 1 nanosecond. Each line of text uses the format px, py, pz, vx, vy, vz. So for example, the hailstone specified here has initial x of 20, y 19, z 15, and velocity of x1, y negative 5, z negative 3. After 1 nanosecond, the hailstone will be at 21, 14, 12. Perhaps you won't have to do anything. How likely are the hailstones to collide with each other and smash into tiny ice crystals? To estimate this, consider only the xy axes. Ignore the z axes. Looking forward in time, how many of the hailstones' paths will intersect within a test area? The hailstones themselves don't have to collide, just test for intersections between the paths they will trace. In this example, look for intersections that happen with an x, y position, each at least 7 and at most 27. In your actual data, you'll need to check a much larger area. So if we do 7, 27, these two will cross at 14.333 and 15.333. These two will cross here, and so on. So these two don't intersect at all. So in this example, two hailstones' future paths cross inside the boundaries of the test area. However, you'll need to search a much larger test area if you want to see if any hailstones might collide. Look for intersections that happen within an xy position, each at least that number and at most this number. Disregard the z-axis entirely. So considering only the x and y axes, check all pairs of hailstones' future paths for intersections. How many occur within the test area? Okay, so we'll start off by grabbing that, putting that here, and I'm going to make a class. Class hailstone, and we'll do init, and we'll do py, or pz, px, py, pz, and then, and then vx, vy, vz, and we will just assign those all to it. Okay, we have that class, so what we'll do for line NF, we are going to get the line, and we're going to replace the at with a comma. As you can see here, it will do this, so now they're all comma separated. Then we will do some regex, and we will do line equals re.sub, re.compile. Hopefully we can just grab spaces like that, replace with nothing, and line. Then we'll do values equals line.split on comma, and let's just print to see what that's doing. Okay, we need to also r.strip. There we go. So now we just need to add the hailstone in. So with that done, we'll change this to hailstones, and we'll print hailstone 0.pz or px 19. Cool. So I've now got that all set up, and we need to make a start with the intersecting. So we'll do min equals 2, not 2, min equals 7, max equals 27, and we'll also make it, just for preparation and time, we'll also add these in, but we'll leave these commented out, and we'll create a function def intersect hailstone 1, hailstone 2, and I guess let's look up the math for this, because I'm not actually sure. Calculate intersection of point of two lines, maybe? Search for just Python code. Okay, so I guess we'll look at this and see if we can use it in nows. So we currently don't have like a proper line, I guess. So that is something that we need to do. Let's do def find end. So pass in a time, and time will basically, let's do self.end x equals self, I forgot to put self into here, self.px times self, this should be plus self.vx times time. And we'll just do the same for everything else. Okay, I misunderstood. I thought these were like durations, not XY positions. So we'll do min, max, and we will do while self dot, actually can't do that. We'll do end x equals min plus 1, end y equals min plus 1. We will do while end x greater than min and end x less than max, and then just the same thing for end y. We will do end x equals, actually no, we'll do equals this, and we'll just do self.end like that, and then we can just do self.end plus this. So let's do hailstones 0 dot find end 727 print hailstone 0 dot end x dot end y. Not supported being string and int. Okay, that's what I forgot to do here. Need to convert it all to an int. Okay, well apparently that's not working. Okay, so of course that's not working. This should be plus equals. Okay, 719. So minus 2. How long would that take? That would be 6 to get to 7, and 6. Okay, that's working. Good. So now onto this. So intersect h1, h2, and we'll do for hailstone in hailstones, hailstone.find end. And now we'll take a look at this. Although what we need to do, so total equals 0, then for I hailstone in hailstones, this is meant to be enumerate. Actually, this will be h1. Then for h2 in hailstones, actually this will be up to the last one because we can't go on any further, and then we need to do 1 onwards. What's wrong with this? Wait, what does it mean it's not enclosed? If I copy this exactly, would it work? Oh, I didn't need this. There we go. We'll do value equals intersect h1, h2. Okay, so now that we've done that, we will do this. Let's just copy and paste all of that into here. So I assume this is so h1 dot px minus endx, and we'll just do the same thing here, py dot end y. Now this is the same thing, but it's going to be h2. In this example, what is it trying to do? I'm not sure what this spread means. Okay, for this, let's just return false, then return true. Actually, maybe we should just do that. And that should be I, not 1. So I got value. If value total plus equals 1. Okay, let's run that and see if it works. Alright, I need to actually return total 5. Okay, well that's not correct. Okay, well let's print, actually we'll do it down here. Print I, which is it, print h1.py, h2.py, oh, px, py, that should be h1, then same thing again, h2, h2. Okay, so 19, these two are inside, and these two are inside, 19, 13, not 19, 13, okay, apparently those don't intersect ever. Maybe I've got the wrong equation for this. Okay, so I found this equation. Maybe this will work. So I'm just gonna comment all that out. And let's do px equals h1 dot p. Guess we can't call it px. Put a capital px dot px times h1 dot end y. And that is minus h2 dot h1 dot py times h1 dot end x. So that's the first bit. And then it's times h2 dot end x minus h2 dot end y. And this is minus, we'll cover the whole thing in brackets. So it's then minus h1 dot px minus h1 dot end x, and this is multiplied by, I think it's this, Wait, no, it's more than that. Copy all of this. So that's times by this. And this should be h2, 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 h2. And then when we have all that, we need to divide it by h1 dot px minus h1 dot endx times by h2 dot py minus h2 dot endy, and then these minus by, I think it's just these two gets minus by, but it's h1 dot py endy x x. Got no idea what that is going to do, but let's just print it. Division by 0. Actually, when the two lines are parallel or coincident, the denominator is 0. Actually, let's just do x denominator. Where's the divide? Right here. And we'll print x denominator. So I guess this means if either of these is 0, I think it's saying if it's 0, then it's if x denominator is equals 0, return false. Okay, maybe we don't even need the px part, and we just need this part. So paste that here, and now we'll do the y denominator one. So this, okay, that all stays the same. So maybe you just need that. Okay, return 0 for all of them. Do we have the correct one? h1 px, h1 index, h2 py, h2 endy, h1 py. Okay, appears to be correct. Oh, maybe return true. We forgot to do that. And it's still returning 5. Have I done this wrong or something? With paths crossed in the past. Okay, that's the mistake I'm making. Okay. I'm not sure what to do for that then. I don't know. Calculate if two projectiles will intersect. I don't know, search for Python. Maybe what we could do, so these cross but they're outside, we could find the actual x, y coordinates and see whereabouts along the line it is. I don't know. Nah, I hate these math questions. I don't know math. I'm just gonna search for someone else's solution because I got no clue what I'm doing. Okay, so I found someone else's solution. I'm just gonna copy theirs because I got no clue about any of this math. And I don't want to waste my time trying to figure out this. So we'll go a1 equals h1 dot, I think they're using the velocity. It's hard to tell what they're actually doing. Yeah, I think it is. So h1 dot vy divided by h1 dot vx. b1 equals h1 dot y minus a1 times h1 dot x. a2 equals h2 dot vy divided by h2 dot vx, and then b2 equals h2 dot y minus h2 times h2x. So they've got math imported, and they are doing if math dot is close. I'm not sure what this is. Determines whether two floating point values are close on value. Sure. So a1, a2. Then they do the same thing here, but with b1, b2. We can return false. And now cx equals b2 minus b1, b1 divided by a1 minus a2. Then cy equals cx times a1 plus b1. And then they're checking to see if it's actually in the future that they collide with each other. So in future equals cx greater than h1 dot x equals h1 dot dx, h1 dot vx greater than 0, and cx greater than h2x is equal to h2 dot vy greater than 0. Then just return in future. I think that's all that needs to be done. Oh yeah. Whoops, I forgot the p's here. And also there. I think that was all the places I missed it. Nope, there's also b2 right there. So let's run that. Nope, still an issue. Float division by 0. Oh, if it's 0, then what do I do? Oh, I did an index here. That should be px, but that doesn't change anything. Like I said this year, I was meant to also return false here. Although I can just get rid of this statement, but we'll just keep it like that for now. It's returning 6 now. What? Okay, no, I'm actually meant to also return these. Okay. If value. Okay. Now we'll do x, y equals value. And we will do if min is less than x, which is less than max, and same thing again, y less than max, then total plus equals 1, 5. Oh, actually, I forgot about this, future. So, if future, and this, now will it 3? Why is it giving 3? Okay, there we go. I'm not sure what changed just then, but I've now got 2. I'm so done with this, and I'm just copying someone's code. Yeah, I'm definitely going to be copying part 2, so I just can't be bothered with this, but I'll go through anyway. So you run it on the actual input. Well, this has been running for quite a while, so I might need to stop it. And I'm just going to take a look at enumerating this, seeing why it's taking so long. Because I wouldn't have thought it would take that long. So print I2, I1, I2. Okay, what's getting stuck? Oh, maybe it's that. Oh, must be this. Okay, didn't think of that. Get rid of this. Yeah, that is definitely the problem, so now let's run it. Oh, that ran instantly. Okay, well, grab this, put it into here, and that is part 1 completed. Upon further analysis, it doesn't seem like any hailstones will naturally collide. It's up to you to fix that. You find a rock on the ground nearby. While it seems extremely unlikely, if you throw it just right, you should be able to hit every hailstone in a single throw. You can use the probably magical winds to reach an integer position you like and to propel the rock at any integer velocity, now including the z-axis in your calculation. If you throw the rock at time 0, where do you need to be so that the rock perfectly collides with every hailstone? Due to probably magical inertia, the rock won't slow down or change direction when it collides with a hailstone. In the example above, you can achieve this by moving to position 24, 13, 10 and throwing the rock at velocity -3, 1, 2. If you do this, you will hit every hailstone as follows. So it applied 5 at this time, 3 at this time, and so on. Above each hailstone is identified by its initial position and its velocity. Then the time and position of that hailstone's collision with your rock are given. After 1 nanosecond, the rock has exactly the same position as one of the hailstones, obliterating it into ice dust. Another hailstone is smashed to bits. 2 nanoseconds later, after that, another total of 6 nanoseconds, all of the hailstones have been destroyed. So at time 0, the rocket needs to be at x position 24, 20, 13, and 10. Adding these 3 coordinates together, it produces 47. Don't add any coordinates from the rock's velocity. Don't determine the exact position of velocity the rock needs to have at time 0 so that it perfectly collides with every hailstone. Well, there's definitely no way I'm going to be figuring that out on my own. So I'm happy I decided to cheat on that. So I guess let's make a start by copying all this. And I'm going to have to just copy someone else's for part 2 because I got no idea how I would work that out. So quite a lot is different in this. So we can remove everything for now. So with our hailstones, we are creating 2 lists. There is S and then SD. Then for H in hailstones, s.append h.py plus h.px plus h.py plus h.pz. And then, so this should be SV. Then SV Vx plus Vy plus Vz. So we've got that. So for SVR in range -1000 to 1000. If SVR in SV, we want to continue. So if we're going the same speed, then we are parallel to it. So if it's not going the same speed, meaning it can't ever be parallel, we're creating a variable m and s. This is a list of lists, and this will be for SI, SVI in zip, SSV. We are then doing SVI minus SVR, comma SI modulus SVI minus SVR. Okay, well I got no clue what that's doing. So next it's for I in range length of m and s. If m and s 0 less than 0, m and s 0 equals minus it. Why does it keep going to a wrong new line? Okay, there we go. And then m and s 1 equals m and s 1 plus m and s 0. Oh, I missed the fact that it should be this in all of them. So I'll copy this all over. Now it's m and s dot sort using a lambda p of p0, and we want reverse sorting lambda. So m equals list, s equals list. Now we're apparently removing non-coprimes. So while m and s, m s I equals m and s dot pop, then m dot append mi, and same thing for here, s dot append, and then m and s equals m j s j for m j s j in m and s if math dot gcd m j m I equals 1. Okay, well, I got no idea what this next section is. So they've created a new class, Chinese remainder constructor. Okay, def init self bases. I mean, at this point I may as well just literally copy what they've written. So I got no idea what's going on. So self bases pi. Yeah, I got no clue what's going on. I know nothing about math. So they've got rem like that, and this, then multiverse or something, and this, and then they have a method which gets called, which then does all this. So I got no clue what any of that is. And then it's back here, s and r equals Chinese underscore remainder m s like that. Why isn't that working? Do I need to do this? Yes, I do. Then if all, okay, they've also got a method for is positive integer, which takes in x, return x greater than 0, and math dot floor x equals x. So they've done that. Then is positive integer. This takes sr minus si divided by svi minus svr. I don't have an svi, so does their code just straight up not work? Okay, I misread it. So for si svi in zip sv. There we go. And for this, I think it returns sr. Where does sr start? Is that what should get returned? Seems like it. Well, I got no clue what it's doing, but let's run it. And it returned 0. So where did I go wrong? SSV hailstones. This is seemingly correct. Wait, why is it getting both as 0? Do I need to keep it as this? No, that's giving 0. But why would this give 0? For part 1. Okay, that's why it's returning 0 here. So this is never happening. Did something else change when I did this? I mean, I don't think so. Okay, well, I am going to copy what was in here to here, and I'm going to undo all this. Cool, it still returns 0. Well, part 1 was returning 2 before. What did I change? Oh, it was this that was changing before. Okay, so if I redo all this, and we change these two. Okay, that's still working. So I can ignore that. But that doesn't answer why part 2 is not working. Okay, I'm now getting the correct value, so I had to redo all this, and I noticed on theirs they are printing the value here, but when it prints a number twice. The first one 19, second one 47. Not sure why you'd have multiple results, but 47 is the correct answer here. So I guess we'll try the real input and see if we can get the correct answer. So let's run that, and we got this number. Just Okay, let's see if that's correct. Okay, cool, that is correct. So, I got no clue about anything about part 1 or part 2 for this challenge, which sucks, because I at least wanted to get part 1 for every single day of the Advent of Code this year. So, you know what, hopefully the next day I can actually complete it. So, other than that, if you like this video, make sure to like and subscribe.